Hello, my name is Logan Malone, and for my 3D design project I decided to make a V engine. As you can see here with my MotionGen Pro schematic, I essentially have the ground here, which represents the block. I have a link right here which represents the crankshaft, and then I have these two links representing the connecting rod and piston assembly. Furthermore, I also have these two slotted links here which represents the cylinders. Now as I play this, watch here, you'll see as the crankshaft rotates, these two pistons, conrod assemblies, will move up and down the cylinder, which mimics a combustion process of an engine. Now if I pause this here, now you may be wondering why I chose to do an engine as my design. Well, simply put, I love cars. I've loved cars since I was 9. I worship it pretty much, and I have a genuine passion, which led me to go to Tennessee Tech and pursue a degree in mechanical engineering with automotive concentration. Yes, that is a degree. Look it up. Y'all provide it. And anyway, which leads me to my next point of the type of engine I decided to make, which if I downsize this, you will see, ta-da! I decided to go a hair bit overboard and full-on design a V12 engine. Now, this design is not from scratch, mind you. It is based on a YouTube video I found from this guy. I forget where he's from, but anyway, he put this online about several years back, and it's essentially a V12 design that, in SolidWorks. As you can see here, it's full-on. It's got, areas for crankshaft, piston, cylinder walls. Okay, this is getting weird. Go back to isometric here. But as you can see, though, it's, an engine design. Now, one thing I will note, unlike his previous design, or unlike his design he had on YouTube, I ended up having to modify it a bit just to, accommodate for a few things. For starters, I squared off the top of this block, for more stability. Furthermore, what he had in his design, he had an open deck, which essentially, as you see these slots here, they were not connected to the cylinder. So essentially the cylinder was kind of free, which is not good, as it, essentially causes, lots of disturbance, vibration, and, well, it would probably cause the engine to pull up, so I ended up going closed deck on that. Which, anyway, it's, better that way. But, put it this way, unfortunately I was not able to actually build that. As you can see in my next design, I had to greatly simplify that. Let me go back to isometric here, sorry. This here is the simplified version, which essentially is the same design as the other block, just, simplified because, well, reason why I simplified it is because when I went to go 3D print my original design, well, it was a little too big, and, well, it would have taken 4 days to print. 4 days, and the iMaker space only allows for, well, 24-hour prints, which, if you do the math, ain't gonna fly. But anyway, I managed to essentially modify it and create this, which, similar design, same essential, or essentially the same thing, just simplified. But move on. So, which leads me to my next point, the crankshaft. This was the second thing I designed, which, if you ask me, is one of my favorite things I had to design. Essentially, this is the V12 crankshaft. As you can see, it's kind of got a cross-plane design. This, it's very detailed, and I just put a lot of love into it. Then again, this is just a giant love project. And thank you again, I will say, to Dr. Canfield, if you're when you're watching this, thank you for giving me an excuse to pursue my love project, which started this past summer and just kind of put aside, and now you actually gave me an excuse to work on it, so thank you. Moving on, though, to the actual crankshaft that I ended up designing. This essentially is the same crankshaft you saw before, just modified so, it can fit the V-twin design. It's, similar, modified, Now I will note too, one thing I did have to modify, because the guy in the YouTube video did not account for this, is clearance. So I ended up having to kind of shrink these joints right here. So these are not exactly to spec of the video, but you know, for sake of clearance and the ability to rotate the damn thing, yeah, I just redesigned that. Anyway, moving on to the piston, which is the second thing I designed. Let me move this around here. Sorry, I was recording this earlier and forgot to do that. Anyway, it's a simple piston design. It's a flat top piston with, you know, double, with a dual kind of ring design right there, and a ability to put a pin inside here. Now, what this does essentially is, well, it's a piston. It allows for, you know, moves up and down the cylinder wall. But yeah, so design that. Next, rod cap. So this, oh, go back. Conrod, here we go. Sorry. This guy is the connecting rod. This is essentially what connects to the crankshaft to the piston. This was, well, you know, it's a simple design, really. Not real much to it, but you know, it's pretty good. It didn't take too long to model. But yeah, that's essentially what it does. Now for the rod cap, here we go. Back to this guy. This essentially connects that connecting rod and the crankshaft. It ultimately holds the connecting rod and the crankshaft. You know, keeps it from flying out. Which I will note, the connecting rod that I ended up modeling ended up breaking, and yeah, I shot a rod. I sent it to Pluto. So, nah, I'm joking. It just fell out, and I'm gonna have to remodel this because apparently the hatching on the inside of this 3D model was, well, crappy. It just I forgot to do something when I initially 3D printed it, but you know, the mechanism still works. It just fails after a few rotations. But yeah, this is essentially a model of this. Fun stuff. Anyway, moving on, window, to the crankshaft bearing. Now, the crankshaft bearing ultimately holds the crankshaft to the block. That's all I have to say, really. I mean, this is it. This is it. Anyway, moving on to the gudgeon pin. Gudgeon pin? Anyway, I cannot pronounce that for the life of me. Anyway, this essentially slides into the hole you saw in the piston. It connects the piston and the connecting rod together, so it allows for, you know, connection, while also allowing the connecting rod to rotate, because, you know, as the crankshaft rotates, there will be sort of rotation between the connecting rod, and, you know, there will be sort of some rotation. Anyway, that's something I had to do. Furthermore, I will note too, when I initially designed the connecting rod, I did not account for clearance, so I ended up having to take a file and just filing it down. So I just slide this thing in, and yeah, did that. That was fun. Anyway, moving on. What's next? Crankshaft bearing, crankshaft. Oh yeah. Small windows. What did I also have? Oh, last but not least was the base. So when I initially printed out my block, I forgot to account for the crankshaft, the actual, you know, the ability to rotate it. Because, you know, I could essentially not have designed the base and just held it, but rotating the crankshaft, having that shown, recording it, and holding it at the same time wasn't going to fly, because for starters, I don't have 3 arms. So I decided to design a base. Now, I could have just designed this as one piece, but, you know, I don't know. It was something I came up with on the fly. Furthermore, if I went with the original design, it would have been an actual oil pan, but that wasn't exactly kind of a box design. Furthermore, if I went with the oil pan design, you couldn't see the actual inside of the engine. You know, with the, you know, where it shows the crankshaft and the actual rods inside. Now, with that said and done, let me move on to my pictures here. Yes, also I do have a lovely artist, or little piece of art here, which is yeah, I don't know where it came from. I just looked it up on Google. Looked cool. Anyway, moving on. This is the block assembled. Forgive the shoddy hot glue work. I'm a terrible hand at that. But essentially, this is it printed. I'm very happy. I'm very glad it got done. This was a lot of work. Anyway, this is what it looks like on the inside, fully assembled. As you can see, you got the rod caps here, you got the rods here, the crankshaft bearing, the crankshaft, the block, and you can see the pistons in there. And then you have the actual stand here, hot glued together. It's kind of a mess. I'm terrible with a hot glue gun. If you don't like it, well, sorry. Now, last but not least, you'll see here it actually in motion. To be honest, this is probably one of the happiest moments in this entire design process. Alright, let's play it. Ain't that wonderful? Well, I hope you enjoyed this video, and I know I did. As Josh from Let's Game It Out says, it's also a YouTube channel you need to watch. He's really funny. Usually just essentially what he does is he takes games and he plays them in the worst way possible. He essentially tries to break a game, but that's down a whole other rabbit hole. Anyway, yeah, I hope you liked this video, and yeah, I mean, I'll put a lot of love and a lot of effort into it, and this is genuinely one of my favorite things I've ever done. So thank you again for giving me an excuse to do what I love. Anyway, yeah, bye.